Welcome to the Coastal Communities 2150 Interactive Sea Level Rise Visualisation of the Lower Ouse. I'm John Parry, Director of the Lewes Railway Line Project, and I work with the Coastal Communities 2150 project locally as a member of the Coastal Futures Group. I'll be your guide to the fly-through, explaining its features and what long-term sea level rise, as a result of climate change, could mean for the Lower Ouse Valley. The visualisation has 4 flight paths for you to follow. Once started, they each run automatically. You can pause or select a different route at any point. The controls allow you to speed up or slow down your journey and pan left, right, up and down. When paused, the slider at the bottom of the screen can be used to fast forward or rewind to a particular point. Pressing play resumes the fly-through from where you paused it. Infrastructure such as railway stations and major roads are highlighted in the bird's eye view in the top right corner to aid orientation. By selecting Seaford to Lewes, we start our flight from Seaford Head, travelling westward along the coast to Newhaven and then turning inland. The sea level shown at 0 metres represents an average annual spring high tide. It's important to remember throughout that the water level shown is the furthest extent of high tide, which will drain down as the tide ebbs. The visualisation shows an increase of sea level by up to 5 metres above the starting height, representing several centuries of sea level rise. Sea level rise in the south east of England could be as much as 1 metre over the next century. The surge from an extreme storm now could cause the same amount of flooding on the coast that occurs with 0.5 to 1 metre rise of sea level if it coincided with a high spring tide. Seaford Shingle Beach is a man-made sea defence requiring annual maintenance. When we add sea level rise, you can see the high tide line move further up the beach. With a very extreme 3.5 metre rise, we can see the sea overtop the beach in front of the Salts Recreation Ground. Passing over Bishopstone as we approach Newhaven, you can see that a metre of sea level rise would cause the River Ouse to fill its historic channel. The mouth of the Ouse became artificially fixed at Newhaven to create the port. Otherwise, the mouth would naturally move between Seaford and Newhaven. Turning the corner at Newhaven, we see the familiar view of the port and the town which has been developed up to the riverbank. With the present level of defence and half a metre of sea level rise, some buildings will flood. A rise of 1 metre is very significant for the east bank of the river, flooding the railway line and both stations. The energy recovery facility was developed on raised ground to withstand sea level rise up to 1.5 metres. We can see that defence working as we raise the sea level. Heading out of Newhaven towards Piddinghoe, with only half a metre of sea level rise, the river will overtop the flood banks. The historic meandering course of the river can be seen very clearly, as well as the raised banks of the current route. The Environment Agency have yet to decide how to manage these embankments beyond the next 14 years into the middle of the century. Between a half and 1 metre of sea level rise, we see a major increase in the flooded area, including the A26 in places. All the way along the valley, we see the floodplain filling up with half a metre rise of sea level. Picking up our flight again at Lewes, we see how half a metre of sea level rise causes the river to spill into the floodplain. The centre of Lewes is protected by the existing defences on the river. The comparison with the floodplain north of the town is dramatic, where the present course of the river is lost. At 2.5 metres of sea level rise, the town centre is flooded. Because of its location in the catchment of the River Ouse, Lewes is also at risk from fluvial flooding, in other words, from swollen rivers due to heavy rainfall. At high tide, the rainwater coming downstream is prevented from flowing away into the sea. If there is a very high volume of water in the river due to heavy rainfall, then it could overtop the banks, as it did in the year 2000. The visualisation only shows the effect of sea level rise and not the effect of intense rainfall in the catchment of the Ouse. Coastal Communities 2150 is using tools like this visualisation to raise awareness of the long-term impacts of climate change. Well-informed communities will make better decisions for their futures. Adaptation should be a positive process that begins early to take advantage of all available opportunities.